Question from distillation is, what are the applications of distillation? Number one is separation of volatile oil. Example, volatile oil separated from clove oil, eucalyptus oil and anise oil. And B is purification of organic solvents. Example, number one is simple distillation is used to determine the boiling range of a liquid. And number two is azeotropic distillation is used to get absolute alcohol, that is 100% ethanol. So azeotropic is actually same boiling point. Okay, so afterwards we will discuss this azeotropic. Number two question, define ideal solution. Actually, in such solution, component does not change other than dilution when they are mixed to form a solution. Example is methanol and water. The third question is, what is Raoult's law? In Raoult's law, it states that the partial vapor pressure of each volatile constituents is equal to the vapor pressure of the pure constituent multiplied by its mole fraction in the solution at a given temperature. So here Raoult's law is equal to, or it can be mathematically expressed as, partial vapor pressure of a liquid is equal to vapor pressure of pure liquid into mole fraction of the liquid. Okay, so here actually PA is the partial vapor pressure of liquid A and PB is the partial vapor pressure of the liquid B. Okay, and P0A or P0A XA, that is actually P0A and XA. XA is equal to the mole fraction of liquid A, that is fractional concentration, and XB is the fractional concentration of liquid B. So here P0A KPA, that is actually vapor pressure exerted by pure component A, and PB P0B kPa, that is kilopascal, a vapor pressure exerted by the pure component B. So PAKPA, that is actually vapor pressure exerted by A, that is liquid A, and PBKPA is equal to vapor pressure exerted by B. Okay. Is number 4 question, what is Dalton's law? The total pressure exerted by a mixture of ideal gases may be considered as a sum of partial vapor pressure exerted by each gas, if alone were present and occupied the total volume. So here actually total vapor pressure is equal to partial vapor pressure of A and partial vapor pressure of B, that is P is equal to PA plus PB, or it is equal to P0AXA plus P0BXB, that is addition of the vapor pressure of pure liquid into mole fraction of the liquid of pure component, both pure component A and B. Okay. Next question number 5, that is define real solution. So here you may get confused that define what is the difference between a real and ideal solution. So what is positive and negative deviation? Most systems show varying degree of deviation from Raoult's law depending on the nature of the liquid and the temperature. These solutions are known as real solution. So that is positive deviation in some liquid system, the vapor pressure is increased than the sum of partial pressures of the individual components, and in case of negative deviation, the vapor pressure is decreased than the sum of partial pressure of the individual components. That is, suppose calcium tetrachloride and cyclohexane, benzene and alcohol are the examples of positive deviation, and chloroform and acetone and water and nitric acid are the examples of negative deviations. Number 6 question: why the principle of real solutions are important in distillation? So why you are considering the real solution principle very important in case of distillation? Actually, complete separation of the component of mixture by fractional distillation may not be achieved if large positive or negative deviations from Raoult's law are observed. Such solution form azeotropic mixture. Therefore, the principle of real solutions are important in distillation. Actually, if azeotropic mixture occurs, no. So what happens? It is very difficult to separate the solution. So if actually there is larger positive or negative deviations occurs from Raoult's law, then actually the separation cannot be possible. So here complete separation of the components may not be achieved. Next is define relative volatility. When the volatility of one component is expressed in terms of second, in case of a liquid mixture containing two components, it is called as relative volatility. So when you are actually going through relative volatility or relative, that means what? You are actually comparing one with the other. So relative volatility, actually alpha is equal to volatility of compound A by volatility of compound B. That is VA by VB. Second, 8 number question: why simple distillation is called as differential distillation? Here the distillation is based on the differences in volatilities and vapor pressures of the component in mixture. So they may ask you that what do you mean by differential distillation? So that is nothing but simple distillation. Okay, so simple distillation is called as differential distillation because here distillation is based on the differences in volatilities and vapor pressure of the components in the mixture. Then question number 9, that is why fractional distillation is called as equilibrium distillation. Here actually separation is attempted when liquid and vapor are in equilibrium. This method is frequently carried out as a continuous process and does not involve rectification. So here the fractional distillation is called as equilibrium distillation. Okay. Another important question number 10. Define azeotropic distillation. In this method, azeotropic, that is constant boiling mixture, is actually broken by the addition of a third substance which a new azeotrope with one of the component is formed. So let us actually describe it with an example so you people can understand. Suppose benzene is added to water and ethyl alcohol azeotropic mixture. So benzene as a third substance, it is added in water and ethyl alcohol azeotropic mixture. So benzene breaks water and ethyl alcohol mixture and forms a new azeotropic solution or mixture, that is benzene plus ethyl alcohol. So here actually water is being liberated and the volatility of water is enhanced at 65.85 degrees centigrade and it is distilled. Now there is left the binary mixture, here is left, that is at 68.2 degrees centigrade. So benzene actually slowly from here, when you are actually heating, benzene is distilled at 78.3 degrees centigrade and alcohol is left. So like that the absolute alcohol been prepared in case of fraction azeotropic mixture from azeotropic mixtures. Okay.